So this video is very purpose-built. It's going to show how to optimize the palette files that you can use when using Layer Manager. And so this is again, you would only use Layer Manager if you're targeting a piece of hardware that has hardware-based layers. The Layer Manager is a pane in Altia design that affords you basically access to the actual properties and attributes of the hardware itself, such as each layer's frame buffer, X and Y position, its blending format amongst other layers, its current alpha, width and height, all that good stuff. We're not going to get into the detail of the Layer Manager itself because again this is really concerning just the palette file optimization to reduce the number of colors used in your GUI, to optimize memory on target, but to also preserve the highest amount of image quality possible when you're reducing colors. Okay, so just for this example here, I've got a GUI, and you can see if I collapse all of this, this layer has about GUI has about 14 layers, I guess 15 because it's base 0. So 15 layers. Within each one of these layers is just a single photo, and we could imagine this being something like a an icon row. You could slide these around using layer X, right? An icon row to select a certain background theme for your GUI, or maybe it's a photo gallery. The point is here that every one of these you can see has a large amount of colors, and so reducing a color palette to a single simple palette across so many different photos, you would definitely get color loss and dithering and bad results if you just tried to use a single palette. By default, Layer Manager is actually, when you use a pal as a color format for the layer, it's going to by default assign auto palette as the attribute for the palette file. And what this does is, if we leave everything just the same, right, and we go ahead and generate code, it's going to, once it gets done, you can see in the Altia subfolder in data.c, it's going to tell you the amount of colors used, and you can find that by searching for p colors. And you can see that per layer, for each of the 15 layers, it made its own separate palette file, and total color count in the entire GUI is 3,315. And here's all the color definitions here. This takes up memory, and it's just one of the steps that you can do to reduce the memory footprint is optimize that out. Okay, so what we want to do is make like a blue palette, blue sort of hued palette, and maybe a green and yellow palette, and then a red and orange palette. And then we're going to assign those common palettes across the layers that look like they could, you know, properly display a greenish palette or a reddish palette here. Let's go to, that would be like a green and yellow palette. And then we would do like maybe a yellows and browns. We could probably almost include the browns amongst the yellow. And then for things like this, we'd probably create a blue palette, also for like the sunsets and oceans. And then there was one in here like this, and then there was a lava and a red flower one in here somewhere. There it is, and then lava. So this, and something like this, or certainly this, could fall within like a red-orange palette. The idea is you don't limit the colors yourself. You let your eye choose what colors appear common, and then you let Photoshop limit the color palette to 256 colors. All right, so there's a little bit of process here, but in the end, it's worth doing if you want to eke out the most memory savings while preserving image quality. So, like many things graphics related, this actually starts off in Photoshop. What I'm going to do is use a Photoshop built-in script called load files into stack, and I'm just going to go find the photos that my GUI is using here. This is just that same folder where the GUI was. And I'm just going to load them all. Since there's only 16 in this case, I'll load them all up here using this script. Basically what this does is it takes all these files, opens them, and puts them into a single stack of images, or I should say layers, because it's making a single layered PSD file from these many files. Again, that's built into Photoshop. It's a script called load files into stack. And so when this gets done, I'll begin the process of showing you how you can commonize a palette and then create a palette generation image, kind of a term I came up with, that you can use in a new GUI with a display object, and actually generate a custom palette amongst commons to be used amongst common images. All right. So this guy's almost done. In fact, that is done. Now, there's a variety of things. One thing I like to do when I'm doing this is make a large canvas. So something like, I don't know, 1,000 by 1,000. That might be too large because these images are small. And in fact, see how the preview of the icons got kind of small? I'm going to undo that real quick because you can take advantage of the fact that you can see a little preview, and you can just start visually ordering them. This just makes showing and hiding the layers properly later easier. And see what I'm doing? I'm putting like blue next to blue and red and green next to red and green. So here's our greens and yellows. This is pretty brown too, so and it's got the blue skies of this field, so I'm going to keep that there. This looks much more red than any sort of green, and this being blue. So I'm just sort of right now commonizing this sort of palette, and this palette and this palette looks similar. So basically, I think I can probably get away for this process with 3 palettes. I'm going to have the palette that covers blue sky amongst greens and yellows and browns. So that would be these guys. Then I'm going to have a palette that does, actually I'll probably include that image too, the reds and oranges. That'll be this group here. And then all the blue guys. I'll do that here. Now getting back to why I say I set the canvas as large. Well, this is part of the trick here that allows your eye to actually confirm that what you're doing netted you good results. So using the select tool here, if I hold down the control key, I can click a layer and then just start dragging it. The reason I want to do this is I want to set them apart from each other so I can see all of them together, right? So notice how I pre-grouped them together in the layer list. That was just for convenience. You didn't have to do that, but now all my blues are right next to each other and easy to show and hide. And in fact, if you want, you could even, group them and call it blues. It's up to you how you organize this for this process. The idea is get your layers visible amongst the common representations of a palette. And by the way, I have 15 images here, so I just did this on all images. If you have 400 images or something, just get a subset of the images that is representative enough to handle falling within a color gamut of a certain palette. So you might have 400 different fire and lava images. Choose a few that represent, the highlights of that type of palette, and you use those for your reds and the orange palette. And then choose a few of your bluish images. And these could even handle, this palette could even handle blue button states too. It doesn't have to be just for photos. But what you want to do is create a subset of imagery that represents a good available set of colors for any given palette. And this, as I said, is going to be primarily our blues. And see the tan here and the tan there and the sunset, that's not going to degrade the palette too much, and the rest is primarily blues. So why do you do this in the first place? Well, the first thing you want to do is make a new image out of just the representative color set. So some Photoshop trickery here. It's Control-Shift-C for copy merge. That command is also right here. And then Control-N for new. And then you just Control-V for paste. This makes one image out of those representative samples of layers from the previous Photoshop file over here. The reason we make one image is what we want to do is change the image mode. This is where the actual paletization really starts happening. Once you say image index color, you can have the option of real-time preview with this checkbox of changing your palette. So let's say I choose 12, right? You could see that all that dithering and banding, and especially if I zoom in, which I'll do in just a sec, but it's pretty obvious even right here on this flower that's not looking good. But at 256 colors, providing that each image is relatively the same colors, see we're getting some dither near this sunset, so maybe this guy has to go to a different palette set. We'll have to see. But you can actually in real time check this box for preview original and then paletted. Okay, and so really I'm noticing not a whole lot here, but I am noticing when I preview it, some banding here and some noise there. You want to keep your palette to 256 colors, and you definitely want to keep force to none. But you have different options about your dither method, and noise often looks better. Yeah, look at that. It looks more convincing than the dither. Now it's still making quite a bit of difference there. So what you can do is try different modes like selective or even adaptive. Okay, and what this is doing is choosing 256 colors regardless, but it's doing it with different methods. And then within those different methods, you can try diffusion or pattern, and pattern's looking okay. You know, I might end up moving this image out. For the sake of this video, I'll keep him in though to kind of give you an idea of examples when an image is actually starting to look bad versus good. You can see most of these images, if I preview, they look roughly the same given only 256 colors for all these images. We run into a problem when you start introducing a lot of oranges amongst your otherwise blues and tans though. Okay, so the top of the sky is looking just fine. It's this deep orange right here that's causing our problem. So again, I'm going to keep that in this representative set so we have an example of why you're doing this in the first place. If you let hardware decide, if you try to make a common palette yourself and just let hardware decide, you might get results more like that on hardware. So you want to prepare the images so that on hardware when it's running it doesn't look that bad, right? Let the hardware decide from a common palette of 256 colors. You want to create representative samples and then limit those samples down to 256 colors and then use that as a common palette across images that share that type of color theme. Okay, so having said all that, again, were I to be going to production, I might actually move this guy off, but we're going to keep him in this set, and we're going to, instead of tweak this some more, we're just going to say, actually, just before I finish, I want to figure out which one I like best. I think I like diffusion the best in terms of what it does to the image. So we're just going to keep that. Maybe you reduce this or you turn off preserve exact colors, but you know, you've got some options, and there's additional just general YouTube videos on optimizing index coloring if you want to watch that stuff. For now, we're going to click OK, and we're going to save this image as a PNG. But remember that it's now, the color mode is now index color. So when we save this image, it's really only using 256 different colors, even though this is a fully 32-bit file format, you know, a PNG 24. Really, it's only using the 256 pixel colors that we limited it down to. All right, so you just save that, and you put it exactly where the rest of your files are, next to your DSN. Or if you have your images in an images subfolder, put them there. Just for this quick video, I have everything in a flat hierarchy. I'm going to save this, though, as palgen, short for pal generation image, blue.png. Okay. And then we're going to kill this new tab off and go back to our original. Remember, this is where we started with the layers. We're done with the blues, so now we're going to turn on the reds. And they're all sitting on top of each other right now. So once again, I'm just going to deselect things, select my tool, and just move these layers apart from each other. Okay, so there's my red, and you can see that what was our problem image? This one here. Providing that these blues didn't cause a problem, that sunset would look a lot better in this palette set, because look, we've got a lot more common palettes across the two. These blues may be the problem if we did it with this set, but again, that's part of this process. It's up to you to decide which ones look the best in the representative palette. Okay, so I'm just going to keep this set of 4 here because I want to make a red and orange type of palette for these guys. All right, so as we did before, select that, group, Control-Shift-C, Control-N, enter, and then paste. And then same process for image mode, reduce it to index color. And to give it an idea, if you tried to make every photo fall under 256 with all those photos as a common palette on hardware, it might look something like that, which is pretty bad, right? So what we do is we get 256 colors just for this representative set of images that are mostly reds and oranges. All right. So with that, we can visually tell that with these settings, boy, we're getting a pretty good representation of most of the colors in this type of image. So I believe that we can just kind of move forward with that and click OK. And then once again, save this out as a PNG. And then we'll call this, what did I call it, Palgen? Yeah, Palgen. And we'll call this red, orange. I missed the E on orange, but that's okay. And then we're going to come back here and hide those layers and show the remaining layers. Now, once again, they're on top of each other, so you can just use the select tool, hold down Control, and set them away from each other. You know, this layer set actually would probably be a better candidate because, see, we've got the oranges in there. So were I to do this video again, or if I had to do this for a production project where I had to be pixel perfect, I would probably remove this layer from my original blue set and go ahead and put this image in there, because look, we're going to pull the blues from the skies in these images, and we're going to pull the oranges and yellows from the various foliage and other sunsets. So this is going to be a fairly flexible and all-encompassing palette, but notice that there's a lot of similarity. So as long as the images look visually close to this, they shouldn't lose much quality. All right, in this palette. So I'll call this greens, yellows, and orange. You know, green, yellow, orange, something like that. There is some blues, but we might find actually, because we're doing almost everything but a lot of reds, we might find that we're going to lose some quality. So let's find that out. Again, it's just kind of part of this process here. But this process allows you to visually confirm all this before it gets on hardware. So I did the Control-Shift-C, Control-N, basically copy, merge, file, new, and paste. And that just so you have it all in one layer, because you want to convert it to index color, and it flattens everything to one layer anyway. This dialog is up, and we've already seen the results. Here's a poor quality result, and then here's our current limit down to 256, which, to be honest, looks pretty good. If I check and uncheck, I guess I see some noise up in the sky here. Takes away a little detail around the tops of those wheat fields, and maybe a little bloom off the cloud there. The sunflowers look fine. If you were to zoom in on the leaves, you might notice noise on that green, but you know, at this resolution, and then even still smaller on an embedded display, I think this would be just fine. So sometimes though the best dither pattern is noise, so I'm going to choose that. And notice that amongst these sibling images, that sunset kind of preserved quality a lot better than when it just had blue to work with. Basically the palette was going all blue and not providing any oranges, but since there's representative oranges elsewhere, the reduction does a better job. Okay, so we have blue, 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 some blue up here, blue, and then we got oranges and yellows and greens throughout. Okay, so that looks good. And you know what, actually I forgot to tell you earlier on, perceptual is usually the better one. I started playing with it with our sunset, but I usually do perceptual, and for dither I usually do noise. So that's appearing okay. Actually in this case I still like adaptive better. So once again, just kind of play with it. It's visual. The point of this is to allow you to visually select what you think will make your images look the best on hardware. Okay, I'm gonna save this down as the Pal Gen red, orange. We can call this green, yellow, blue. You know, it's really up to you what you call this. I'll just keep it short, green, yellow. Okay, so once you're done with Photoshop, you come back over into Altia Design. So this is after you've saved out your palette generation images, and they're sitting on disk. And what you want to do is either create a blank DSN with a new image, display object, layer manager object with no layers, and just shove the palette generation images into there, or just put new layers in your existing GUI with lots of layers already, so your main GUI. It's just that when you generate code, you'll have to keep track of which layers had the palette generation files, because those are the PAL files that will become important. For the sake of this demo, I'm going to actually use a blank GUI just because it's a little bit easier. Okay, and basically one thing to keep in mind is, depending upon the target, the maximum width of a layer is a limitation on certain targets. Okay, and also if you have layer buffer width and heights that are smaller than the content, that can sometimes cause validator and code generation errors. So if you see those crop up, I want to just mention that ahead of time. That could be the problem. I'm going to be generating code for a rainbow target. which actually, if I have the wrong rule set, I'll just set this back to generic, so it's okay. So I'm going to generate code for Freescale Rainbow, and currently that allows me to create large layers. And so just a heads up, if you're generating for Vibrid, there is a maximum width there to keep in mind. Okay, so having said all that, that kind of prepares the rest of the process here. We need to use those images that we just made, of course, and they're sitting in the same folder as I'm located with my DSN right now. And so I just want to click individually and then copy and paste this image object and then bring that up, and then copy and paste this image object and bring up the third. So we got our red, orange, and yellow ones, and then got the blue one here. Now really all that's left to do is place these relatively on the screen or near to the screen, and go ahead and drag them into the display object. Okay, and this is what I mean by some code generation errors. See how they're going on the screen? Depending upon the target, it might yell at you about that. Okay, so I'll show you how to fix that if that happens. And we're doing for the Freescale Rainbow, which is one of the layer-based targets, and it's going to say, yep, yeah. So it's telling me that I've got some objects that are too wide here. The Vibrid validation rule is similar, and so that's what I was talking about earlier. Actually, you know what? I'll drag this over here so it's taller than it is wide. That might be helpful in this case. It's saying object is too wide. Okay, so it's telling you that you need to reduce the width of the object or increase the frame buffer. And basically for this guy here, because we're doing generation, I could get away with a lot more width. But if I'm getting away with the width and height of both the frame buffer and the layer itself have to be set to something higher, right? As well as the actual animation for the display itself should be changed to something larger than your image content, as well as each one of your palette generation files, layer width and height. And again, depending upon the code generation target, I can't say that, you will actually have to possibly use smaller values, because it will not let you generate code on certain targets for layers with a maximum width or height. Rainbow at this point in time will, so I've chosen to leave it as is, since that's how we made it in Photoshop. Okay, so everything's 1200 by 1200, including the display object itself, which is sitting right here. If we shrink this down a bit, you can see that now everything's fitting. In fact, we've got plenty of space above and below. You might want to check the bounding boxes just to make sure that they're not sticking over or anything like that, and then you can generate code. Again, sometimes I either intentionally or unintentionally have some mistakes come on, so that if you run into it, you can go, oh yeah, I saw that video, and learn how to fix it right there in that moment. Keep in mind though that certain targets will not let you get away with this because it's just too wide. But that's just validator. We're telling it we're going for the Vibrid. If we set it back to generic rule specification, it says okay. And the current version of the rainbow target I'm using has a it doesn't yell at you for that. So let's see. Let's see. Oh, sorry. Also, in order to do this, every layer needs to be set to format APAL. That auto sizes it to within the region of what your content is. So make sure they're APAL. And of course, you need an APAL. That's critical for this video because it's going to generate palette files, providing it's an APAL or a PAL file. Okay. Just another thing to watch out for. There we go. Generated code. And really, the point of this segment of the video wasn't anything to do with validator. What we wanted to have happen right now is this, this, and this. Okay. When you generate code with a representative set of images per layer, like we have here, here, and here, you will basically restrict the color palette within that set to 256, as we did earlier in the video, right? So we know what they're going to look like because we're seeing it on screen because we've already reduced the color. So visually we can confirm it's going to look okay. We know that they represent a good majority of the images that fall within this gamut. And then we put them in a layer to generate code. And what we're going to do now is match. See how layer 0 is the blue one? We're going to actually rename these PAL files. My blues. And you could say blues, whatever you want to call them. And then what's layer 1? We'll call it green, orange, tan, maybe? Or aqua, orange, tan, how about? Since it's kind of bluey green, depending upon the photo. Aqua, orange, tan. And I'll just say, I'll rename this one, just blues. And then I'll call this one reds.pal, because it was primarily reds. Okay, so 3 palette files, 256 colors each. Remember at the beginning of the video when I looked at data.c, there was a lot of p count. I'm going to reload it. Remember we had 35,115 before? Reloading this file now. We've reduced it down to 3 palettes for the entire GUI and only 767 colors, down from 3,000 or something. Now if you had 400 photo layers and each one of them generated their own palette, this could be easily a 5-digit number or more. But because we've now reduced our color set to 3 possible custom palettes, no matter how many layers we have, as long as we assign those palletized layers one of those 3 palettes, our total color count for the entire GUI will never breach 767. I may not do it for all 15 layers just because this video has already gone long. But I want to at least show you how to assign a custom palette to a regular palette. So this was our palette generation DSN. We don't really actually need this anymore. The point, once again, of this DSN and even code generation for this DSN was not to show validator or any of those warnings. It was just get an image on a layer that is already pre-reduced in Photoshop and represents a sample subset, regardless of its width. You know, you might have to play around with the width to get rid of any errors you might see. And generate code. Once you generate code, you get those custom palette files. You then rename those custom palette files, and you go back to your actual GUI. So remember, this was our GUI that had all of the true photos. These would be icons that could possibly get animated with their X values and all that good stuff. That is the portion of the video that this goes away from auto, okay, and it goes into becoming one of the 3 palettes for every single layer in your GUI that needs these palettes, and that would be every layer that's either PAL or APAL. Okay, so you know, we can basically go and it was reds, blues, and one that I forgot because I named it too complicated. There we go, aqua, orange, tan. So I'm just going to copy that one and just show you before I end the video just a few examples of how you would assign this. So this is red, orange, tan.pal, and you can even see that it's taken that change on the current layer to that. But if we go to this layer, it's auto, right? And what is this layer? This is the next layer in the list, which of course is layer 1. We can click on layer 1 to automatically go to those layers 2 in Layer Manager. And this will of course have to be the reds PAL, because that was part of the sunset one that we did. And this one of course would be the blues.pal. So as you can detect, it's a bit of a process, but it will save memory and optimize the amount of colors that is used, and thus the code and the memory that's also consumed, while giving you a method to visually confirm that the color restrictions are going to prove to still be visually accurate, or accurate within acceptable limits, by using 3 palette files for every single layer. Okay, so you get the idea at this point. Go through and give them all one of the 3 palettes. Alright, so without fat fingering typos in there, of course. So that's the basic idea. Again, a recap. Started in Photoshop. We had a file, right? We had a file that had all of our photos in it. We increased the canvas and started grouping the photos representatively together, or you could do this just by, again, using the load files in its DAX script. Once we had representative sets of blues and greens and yellows, we created this composite images, this, and this. And we made those each individually reduced to 256 colors. Okay, and then we took those images and generated code 1 per layer to get a custom palette for layer 0, 1, and 2 in Altia Design. Rename those custom palettes and begin assigning them to the actual layers in your GUI.